Now we come to Newton's second law of motion. Now the second law of motion involves us, or rather gives us two things, which first is the mathematical derivation of the law. So it gives the definition or rather the mathematical definition. And secondly, it tells us something about two things which we call impulse and impulsive force. So we have impulse and impulsive force. Now let us first deal with the mathematical part of the second law. So the mathematical part of the definition of the second law, as we all know, states that the force is rate of change of momentum. So to begin with momentum, it is a product of mass and velocity. And if this momentum is a vector, this velocity is a vector, we have to mind that the velocity change is giving the momentum change. And the change in velocity can take place not only by changing the magnitude just, but by changing the direction also. So it is not that you have to always wait for the magnitude of velocity to change from 10 to 5. Rather, it can be 5 meter per second in both cases when it was initially moving from west to east and then it starts moving from towards north. So in that case, we will undergo a change in velocity. So it has to be taken care of while calculating the change in momentum as well. Now the definition states that the force is proportional to the rate of change of momentum. So if we put it in the calculus notation, it is dp by dt, where we have d dt of mv, and as you know, in most of the cases the mass is a constant. So we have this constant as k, the mass is constant, and you know dv dt, which is equal to acceleration. So we have F is equal to k into ma. Now this k, which is just a constant, is of immense importance because without this k, we couldn't have defined the force. In fact, the method of defining the force is making this k 1. So how is it possible, or how we are doing it? Let us check it out. We say the mass is 1 kg. We say the acceleration is 1 meter per second square. We say that the force is 1 Newton. So the process of defining a 1 Newton force is nothing but making this k 1. So that has to be taken care of. That is the importance of this constant k. Without the k, we couldn't have defined the force. So that gives us ultimately the force in a vector form, which we can write as F is equal to ma, where we have to understand that this force is additive and additive in vectorially, and this acceleration is again additive vectorially. So the second part of the force definition comes to this, that what happens when it is v dmdt, when v becomes constant. Well, that is a very important case of Newton's second law, where we have a variable mass system. And mind you, we are making the constant k already 1 here. So while we define the force, we make the k 1 and then define it. So now this has a very important application in rocket thrust. Say for example, a rocket is moving with a velocity of 100 meter per second, and then it is ejecting the gas at a rate of 200 kg per second. So the thrust happens to be 100 into 200. So that is 2 into 10 to the power 4 Newton. So that is what the unit actually says all about the variation of mass or the variable mass. Whenever you have a unit of kg per second like that, you have to understand that we need to apply this form of force, which is v dm dt, where dm dt is a variable mass. The second portion of force comes to impulse and impulsive force. First, you have to understand that why impulsive force. You see, in normal course, if I have to apply a force on a body, then in order to find the magnitude of the force on the body, I have to apply the force for a fairly long time. Then only the body will undergo a change in velocity, and then I can calculate that what is the acceleration, and then I can find the force by multiplying the acceleration with the mass. Now what happens if this change or the action of force is for a very, very small time duration? So this is nearly about 0. Then what happens? Then we define impulse in this way that di is f into dt. And as you can understand that f into dt means p dv, that is p del v. So I can write it in this form that del I, that is impulse, is f del t, and that is equal to del p, which is m del v. So now this del p and then what we write for m dv can be given in this kind of notation also. So this I is impulse and this is impulsive force. So if you are asked to relate them, that is what is the relation between impulse and impulsive force, is simply the fact that this force is the cause and this impulse is the effect. So that is very important for you to understand that there is a relation of cause and effect between the force and the impulse, or rather the impulsive force and the impulse. So now let us take another case to understand this, that how you calculate the impulse when you are asked to find that the force acts for a very small time duration. You see, we find through a change in velocity. So if I strike the ball with a velocity v and it rebounds with velocity v from the wall where the time duration is very small, then we can calculate the change in velocity as v minus of minus v. So it is 2v. So the change in momentum becomes twice mv. So that is the reason why you can see if two trains collide face on, then there is a very unusual case of the two bodies get thrashed badly. So that is why, because the velocity gets doubled in this way during the time of collision, which is very small. So that is how we say that this is the cause and this is the effect. So that is all for the second law right now. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.